Okay, today we are going to learn integration by parts, and that is for when you do not have a calculator. So right now we already know how to integrate something with two components that are added or subtracted together, and that's kind of like the inverse of our power rule. But now we're going to learn how to integrate something without a calculator that is those same two components connected by multiplication, and the way we do that is with integration by parts. So this is the integration by parts formula. It's our initial integral with two different components, u and dv, and you can just memorize this, and once you assign u and dv, implement the formula. But we're also going to demonstrate how to do this with the tabular method, which just makes it a little bit easier. So what's really important is understanding which component to assign to be u versus dv. You're going to be deriving u and integrating dv. So here are a couple tips just to help you figure that out. If you want to pause the video here and copy them down, that works perfect. But we're going to revisit our example of x to the fourth sine x dx, right? And I'm going to put x to the fourth to be u because it's a polynomial, and that's in our tips. I'll make it a bit easier for you. And sine x is going to be integrated. So over here, I've just derived x to the fourth. And once we hit that 0, that means we have to stop because we cannot derive 0. And then over on this side, I just went ahead and integrated sine x until we matched the length of the column on the left. So now that our chart is all filled out, we added in these diagonal arrows to connect these pieces. And then we have one arrow connecting the bottom two components, and that's going to have an integral. The rest of these are just plus, minus, plus, minus, plus, minus. That is a minus in front of our integral. And that alternating pattern will be consistent throughout all of your problems. So using our components here, I can demonstrate to you the answer. We're going to start with the x to the fourth cosine x. Be aware of that negative that's added there. All right, and then right here we do have two negatives that cancel out to be a positive with the 4x cubed sine x, and then you just continue down the chart doing the same thing. I won't waste your time doing that right now. We just want to make sure that you don't forget that integration constant and always be wary of those signs, which will continue to cancel out or change with each component. So now I have a new problem for you, a little bit more complex. All right, and if you want to pause the video and try figuring it out yourself, that works perfect, or I'm just going to go ahead and work it out here. So we already have our little chart set up, and I have e to the 2x, and that's going to be u, and cosine x is dv. So I'm just going to go ahead and start connecting these. Obviously, I went ahead and integrated on the left and derived on the, I derived on the left and integrated on the right. So plus, minus, and this is going to be a positive integral, just a little bit different from our first example. Okay, and using this, what we have right here, we have the integral of e to the 2x cosine x dx. Don't forget that proper notation. And I just combined these components over here. And what we do end up with is a -4 integral of the same original integral that we had. I just moved that negative and 4 to the outside of the integral sign, which we know we can do based on our integral properties. So I'm just going to use a little bit of algebra to finish up this problem. I'm going to add 4 integral e to the x 2x cosine x dx to both sides, and then I end up, let me just clean this up for you guys. I end up with 5 integral ex 2x cosine x dx equaling our solution. And just some basic algebra, I'm going to divide by 5 on both sides and add an integration constant. And this is our final answer right here. All right, thank you so much.